Right, good evening everyone. Sophia touched in the first talk about words are like really hard to recognise because they have different pronunciations. This one has a lot of different pronunciations. We've got Kubernetes. I'm going to clear it up tonight. It's Kubernetes because I'm from Yorkshire, so therefore I'm right. Okay? So it's Kubernetes. If you want to play a drinking game while I do this, every time I say Kubernetes, drink. You might be a bit sozzled by the end of it. My name is Andy, by the way, as I was introduced. I'm a platform engineer in the Bet Platform squad here at Sky Betting and Gaming. I've been there for 10 weeks, which makes me a veteran at Kubernetes. But I'm going to explain to you my kind of learning path and how I got into this stuff, because I think with tech, as Ian was alluding to before, moving on to that next step and choosing something new, it's always a bit daunting. So I'm going to explain to you how I went from pies to production. And as you can see, I brought my pies with me, which means I'm going to try and do a demo, and there's so much kit on this table, I'm actually scared looking at it now. But we'll have a go. So what is Kubernetes? Well, it's a container scheduling and management thing, according to GitHub. I'm going to call it platform, just to make it easy. It comes from our friends at Google, who were running a system called Borg, which was also a container scheduling and management system. And they took some of their learnings. They created an open source project called Kubernetes and gave it to the world through the Cloud Native Computing Foundation, which is part of the Linux Foundation, so it's a real thing to use, along with a load of other supporting components. Some of you might recognize some of the logos on the screen there. This is a sketch note by my friend Denise, and she's explaining on here about 12-factor applications. Now, it's important when you start thinking about not only containerizing your applications, but when you start running to a container scheduling and management platform, that you bear in mind a lot of these principles. In fact, all of them really would be great. So although you can stick your monoliths in a container, particularly with a platform like Kubernetes, that's not its sweet spot. That's not what we do. Particularly the two that are highlighted, number 6 and number 9 here. They're the important ones. So we need to build our applications so that they're designed to fail, so they're disposable, so that they will recover. We also need to think about our apps being stateless, so we don't store important information alongside our running code. We separate that out. Because that's really where the sweet spot for systems like Kubernetes and other container scheduling and management platforms, you really do get a benefit from it. So when you start learning a technology, you can dive on the command line like you do, particularly if you've used Docker a lot. This is kind of really familiar. You can type all the commands in and you can be very imperative in your description. You can say, I want one of these, and I want one of these, and now one of these, and 2 of these, and 3 of these, and now can we destroy it all? You can build it up very much with instructions. But it's really when you start looking under the hood of technologies like Kubernetes, that you start realizing that there's a lot more going on underneath it. This is the object hierarchy within the API. And at the top, we've got a bunch of stuff that's kind of cluster related. One of the key ones in the middle is this idea of namespaces. And the objects in Kubernetes are divided up into namespaces. So in our case, we would typically give a namespace to a squad who are developing a product or an app, or we'd actually create a namespace for that product and app. And that provides some isolation from everything else that's running on the cluster. So you can separate out things through namespaces. Within the namespace, you've got kind of 4 areas of object, which are workload, service discovery, storage, and config. We haven't got a great deal of time this evening, so I'm only going to cover these ones, particularly deployment, replica set, and pod. These are some of the basic concepts that exist within inside Kubernetes. And what we can do is we can start being declarative about how we put our applications together. Rather than running a script with a series of commands in, what we can actually start doing is writing our application down in a structured file, in a manifest. So this is a deployment manifest. And within it, what we're specifying is something called a replica set, which specifies a number of pods. I'll explain a little bit more about pods in a minute, which have got containers within them. So in this example, we have a deployment which manages a replica set that manages 3 replicas pods. So we've basically got 3 of the same thing running. And there each one of those pods is running a container. That's kind of a wrapper around. Of course, we can throw those configuration files into GitHub and version our releases, and we can update those as we go. So kind of infrastructure as code or configuration management already built into the system. That's not something we're putting on top of it. Our demo cluster this evening is a 5-node cluster. It has one master node, which is running the API. So that's the interface into the cluster. That's what all the tooling talks through, whether it's the dashboard or whether it's the command line tools. And within the master node, there are a number of supporting other services. So there's something called etcd, which is stores the configuration and state of the application and deployments that are running on the cluster. And then between the scheduler and the controller manager, you've got a way of checking that the state of the cluster is as it expects, and it will take action if not. And they work with the kubelets that run on our worker nodes. On our worker nodes, we've got the kubelet and proxy, which provide networking, but we've also got these pods. So in this example, we've got 3 WordPress pods, and we've got 1 MySQL pod. You'll notice that we only have 1 container in each pod. That's kind of best practice. Although there's a temptation when you containerize your applications to stick all of the vertical stack into a pod, that's not the way to do it. That's bad. And what you should do is separate them out into separate pods and let the platform scale them for you. So in our example here, we've got a container in each one of the pods. It's important to realize that this is a resilient system. So if something bad happens with this pod, Kubernetes will spot it, kill it, and recreate another one. Now that might be on the same node, it might be on a different one. I think the point here is we don't actually need to care which node it goes on. We're asking Kubernetes for the what, and it's working out the how, which is really different to a lot of other systems. We let it heal it, and it work it out what it's going to do. That's what it's built for. That's what it's good at. So also in our demo this evening, we have an NFS share, which is running on another Raspberry Pi, because, you know, why wouldn't you run a file server on a Raspberry Pi? So this is my cluster. This is my Raspberry Pi cluster. I will tweet these slides out, so if you want to build one, which is really good fun, it costs you about 300 quid, but you'll learn a lot doing it, and whether you want to run Kubernetes on it, or I run a dupe on it as well, which is even more fun. But I'll tweet these slides out if you've got the links, if you want to build one. So, wish me luck, we're going to do a demo. What could possibly go wrong with a bunch of 5, essentially phone boards? Right, bear with, I have to go hands-free. Feel like Elton John. What? Okay. Right, okay, so this is on the master node, and we've got a bunch of processes running here. I'll zoom in a little bit for you at the back. Remember the key combination? There we go. Okay, and you'll notice in the process list here on the master, we've got a couple of the services we identified before. We can see etcd, an API server, a controller, and a scheduler, all moving around with the various amounts of resource that they're using. I'll come out of that. I just wanted to prove that this was live, and I hadn't rigged it. I probably should have rigged it. Why didn't I think of that? And on this machine, I have prepared earlier a number of those manifest files we saw earlier. These are YAML files. So I'm going to open these up and have a quick look at them. Right, so there's a little extra bit in here for you. This is a service defined at the top. This is actually the way we talk to things over the network. So for MySQL, in this case, we're going to talk on port 3306, because that's what you talk to MySQL on. That will connect itself to the pods, which are running in our deployment, which we'll move on to now. So in our pod definition here, as we saw in the little snippet, we can see the number of replicas. We can see that's 1. We only want 1 MySQL pod running, because otherwise we've got to start doing clever things with replication and clustering, and it's a demo on Raspberry Pis, so let's not do that. But that's our replica set defined right there. Then we have our pods under it, and you can see down here we've got our containers defined, so they live inside our pods. So we've got 1 replica set, 1 pod. Okay? You'll notice down here there's something really, really bad you should never do. This is injecting environment variables in with passwords. Don't do that in production, please. So we now expose the port, and what we're doing is we're mapping onto the NFS server valid MySQL, so that's where it's going to get its files from. So if this MySQL instance were to die and it springs up on another pod, it's still going to have the file path there with the files in, so it can start running the database again. Okay. Meanwhile, on the MySQL side, we've got port 80 exposed on our service because we want to point the web browser at it. And then on our deployment, pretty similar. We've got replicas of 3 this time because we want 3 pods. And then within each pod, we've got our Apache WordPress image, which is going to load up. So, deployment, replica set, 3 pods in the replica set, 1 container in there. Everybody got that? Cool. Okay. Now, what I had planned to do was actually deploy that live, but we thought it might be a bit quicker rather than waiting for the Pi to catch up. We'd actually already do that. But if you were to want to deploy it now, you simply type kubectl. We tell it the command we want to do, apply, and then we just give it the path of the file. So literally do that. And what that would do is that would take that manifest file we'd made, and the Kubernetes running on the Pis would actually distribute the containers as we'd asked it to across the cluster. So, and we start running it. So let's see if it did work when I did it. Okay, so this is the dashboard. There's a number of ways to get into the cluster and start looking at stuff. A lot of the team I work with look at this like they found a skid mark on a hotel towel. They don't like the dashboard. It's also really insecure to put this on a production cluster. Don't do that. But it allows us to see what's going on visually. Normally we'd use the command line tool and use kubectl for everything. So, but let's have a look. So we can see if we scroll down here, we can see everything's green. That's good. That's a good start. And you'll notice down the left-hand side, these names here will match the API objects, which we made reference to in that diagram earlier. So actually they are kind of like exposed through this interface, and indeed the command line tools as well. They are part of the API. If we scroll down the main workload area, we'll see we have our deployments listed here, and we've got 2 of those there, which were kind of familiar to us. Obviously there's a lot of other stuff running on this cluster, but we can see WordPress and we can see MySQL there. If we go further down, we can see some pods. More about that in a minute. We see our replica sets of WordPress and MySQL, a load of other stuff. And then, we get onto some network stuff at the bottom. If I go and look at deployments, we will see 2 we're interested in. If I look at the MySQL one, you see this display of all the details of the MySQL deployment has 1 replica set, and it's saying 1 of 1, which is really good. That means it's created our pod. So let's go and look at that. So our replica set has 1 pod. We can see it there. We can actually look at the logs for it, or we can exec into it from here. You can do that from command line as well. But you see that's running on node 4. So that's that one next to the bottom. If we go to the deployments again, and look at the deployment for WordPress. Again, we've got 1 replica set, but I can see I've got 3 of 3, which is good because I asked for 3. And we've got 3 pods running. So running on 3, 4, and 5. So let's see how fast the Raspberry Pi processor is when we give it a new request. So I'm going to this through the proxy, and it'll take a minute to load up. But just to recap, we've created 2 deployments, replica set in each of them. One of the replica sets has got 1 pod in it for MySQL, the other one has got 3 in it for WordPress. And I could show you how we load balance it, but basically that service we define will send random connections to each of the pods as you hit the front end through this proxy. And there we have WordPress running on a Raspberry Pi cluster, kind of resilient. I could, in theory, unplug some of it, and it would probably carry on working, but I kind of like my little cluster, so I'm going to be nice to it on this occasion. Right, back to the slides. Okay, so that's a real-world working Raspberry Pi cluster. And that's what I learned the stuff on. That's running 1.10.2 for those of you that are aficionados of Kubernetes, so it's a fairly recent version. There are plenty of guides around on how to install it, should you want to do so. I'll tweet them out. But we've only really scratched the surface of what the API exposes there. We've got loads of other objects, and there's tons of clever stuff it does with networking between the hosts, between the pods, how it exposes services out through ingresses and load balancers. That's largely dependent on whether you're running it on your own stuff or whether you're using one other cloud provider. offerings. One of the real sweet things about using it is with scaling and roll out and roll back. If you want to change the container version, you just have to update that manifest file we saw, edit that deployment YAML, and chuck it at the cluster again, and it will start killing off the old pods running your old container and start spinning up new ones. And there's various strategies you can specify of how it does that. So it can start doing it as a rolling update, or it can do blue-green, or you can do a canary deploy. It's really all powered by something called labels, which, for those of you that work in EC2 instances, you're probably used to a lot of tags. It's kind of that, but for Kubernetes. There's a whole lot of ways of storing configuration in objects, so you're keeping your configuration data separate to your actual code, and you're running containers, you're storing them as objects. Again, you can version control those. And it does some secret management, but really you probably want to be using something like HashiCorp Vault for secrets, because it does a much better job. It's got a whole role-based access system in there, and that's not just for who can log in to the cluster and make stuff happen. You can assign roles to the things that run in your cluster and restrict what can access what. So there's a lot of power in there. It's really cool. But I suppose we should tell you what we use it for here, as you've come along. So we have 3 live environments, 1 in AWS, 2 in 2 of our data centers, on-prem, running on VMware. We use something called Core OS, which is really container Linux, and we make extensive use of 2 technologies called Matchbox and Ignition for our configuration of those nodes that we host Coros with, and that's all managed by Terraform. So we're using some newer technologies to do that. If you were to see one of our clusters, there are roughly about 30 worker nodes. Some of them a bit bigger, some a bit smaller. We've got high availability on the masters, mostly configured with CoreOS and Matchbox Ignition, as I said at the bottom. But we've got some stuff that's kind of supporting that's still RHEL and Chef as well. This was kind of the reason we did it. So we already do the kind of DevOps thing with our development squads. They already are on call. They already build it, run it, look after it, get up in the middle of the night when it cries, that kind of thing. They're already doing that, but we wanted to speed the delivery of them writing code and getting it onto servers in production. So that's the reason we did this. The idea being that a developer can build a tool set to deploy how and whatever they want, when they want, without it needing interference or support from our team in Bet Platform or even from infrastructure. And that's something we're working towards, but that's the reason why we're doing it, so we can go fast. That's a competitive advantage in a very competitive industry, and we need to be doing that to stay ahead. So what do we run on it? Well, Andrew would have told you all about the Kotlin stuff that we run as part of the Nexus project. Unfortunately, he's not well. We run our real-time Sky Bet Club analytics on it. That's talking to Kafka, so we'll do some more information about Kafka in a minute. Our trading back office systems are running on there, and this week we've started rolling out our live pricing updates to the site onto there, so that's going to give us an amazing saving on AWS, because that's hosted there at the minute. This is going to allow us to run and more efficiently use the resources we're paying for in AWS, but also speed up how we can iterate on that as we need. There are literally thousands of updates a minute go through that system on a Saturday afternoon when we've got all the football games going on. There are some realities of running it in production. We have to monitor it. We have to wake ourselves up in the night. Fortunately, that's very rare with this system because it's very resilient. And we use PagerDuty and a combination of Slack to do that. All our logs go to our Elastic cluster, which is hosted here, so we've got immediate access to our logs through Kibana front end, so we can see what the pods have been doing and what the system's doing. A couple of gotchas to watch out for that hurt us sometimes, because it's not all great. VPN connections into Amazon, that can be bad when they break. I mean, like, Amazon's going to break, right? Oh yeah, it did yesterday. That can really hurt us. DNS, do I need to say any more about DNS being a problem? It is a problem. That can hurt us, particularly if things aren't updating. And one thing we've realized is we're heavily dependent on our upstream image registry. So Artifactory in our case, because if a pod hits a node in the cluster that hasn't seen the image before, we've got to go and get it off the registry. If that's having a bad day, we have a bad day. Sometimes it's better that it's off than it goes slow, because that can cause equally as much fun. And Evergreen is a team sport. It's changing really, really rapidly, updating really, really rapidly, Kubernetes. It's important that we let and work with our dev squads know when we're going to make changes so that we can coordinate that together, because things can break in such a fast-moving project, so we need to be very, very mindful of that. Resources, if you want to build one of these or you want to play with Kubernetes, some good news here. First of all, you can do it now. If you go to Katacoda, they'll spin you in your browser an instance of Kubernetes up. You can go and play with that right now. There's some books, because people like books, because dead trees are fun. I particularly like this first one, because it's really, really in-depth, and it talks a lot more about the API rather than kind of like run these commands and you'll have containers. But the other two are good. If you've got the latest version of Docker, you've probably already got Kubernetes on your machine anyway, so you can start playing with that. And there is, of course, our old friend Minikube as well, which is probably, I suppose it's now out of date now. We've got Kubernetes on laptops, but you can you can play with that as well. There's lots of documentation around that because it's been around for ages. If you don't want to spend money, good news, the documentation's absolutely fantastic. So RTFM, you don't even need to buy a book. That's my Twitter handle. If you want to follow me, I'll tweet out some links to these slides and some of the resources, or you can just troll me. I don't really mind. I like the attention. So I'm quite lonely on Twitter. And I've gone really, really over, so thank you very much for listening, and enjoy the rest of the talks. Thank you.